Now this is the second part of recorded lab session 4, in which you will see how we implement ensemble average in MATLAB. With reference to the first lab activity, we are supposed to take the ensemble average of 100 responses of visual evoked potentials. Remember, visual evoked response is an EEG signal which is recorded near the visual cortex. This the signals are stored in var.mat file. This var.mat file contains two variables. First is actual var, which we will use later, and the second is var. The size of var variable is 100 by 500. It means there are 100 responses and each response has 500 data points. So the first step is to load the signal. Therefore, we will write command load var. Then there is need to define the sampling frequency of the signal. The sampling interval for these signals is 5 milliseconds. Therefore, the sampling frequency will be equal to fs is equals to 1 divided by 0.005. So this is the sampling frequency of the signal. We will use MATLAB averaging routine mean. Remember, if mean is given a matrix variable, it will average each column. Therefore, if various signals are arranged as rows in the matrix, the mean routine will produce ensemble average. Therefore, the next step is to determine the size and orientation of data. If number of rows is greater than number of columns, then we will need to take the transpose of data. Otherwise, there will be no need to take the transpose of data if number of rows is less than number of columns. It will mean that signals are arranged row-wise. So first of all, determine the size of data. To check the size of data, we will call size routine of the MATLAB. Var will be input to the size routine. Output of the size will be rows and columns. R represent row and C represent column. Now, if rows is greater than number of columns, then we will take the transpose of data. This is the transpose operator. Then we will need to define the time vector for the signal to plot the signal. Divided by fs. If rows is less than number of columns, then there will be no need to take the transpose of data. Here we will generate time vector for the signal. By using this formula. Now end this if expression. Now to compute ensemble average, we will use MATLAB averaging routine, that is mean. Ensemble average is equal to mean In figure 1, we will plot ensemble average with respect to time vector. Therefore, we will use command plot t, ensemble average. We are also supposed to plot individual evoked response to compare how ensemble average reduce noise. Therefore, in figure 2, we will plot individual evoked response. Again, we will use plot command. We are supposed to plot individual evoked response, so we are plotting first signal of the variable var. So this expression will plot first response stored in var matrix. Now run this. Now you can compare two figures. Figure 1 represents ensemble average of 100 responses. Figure 2 represents individual evoked response. That is the first response stored in var matrix. You can see how ensemble average significantly reduce noise by averaging 100 responses. This var waveform is similar to the one which I have described in the first recorded part of this lab session. So the time of this signal is 0 to 2.5 milliseconds. So by completing this lab activity, you can see how ensemble averaging reduce noise by averaging 100 responses together. In the next lab activity, we will see how ensemble average reduce variance.